In this video, we're going to start looking at tangents and circles and the relationship they have. There are two facts that are really interesting about the relationship that tangents have to circles. And so when you're working on your tangent inquiry sheet, what we're going to do in this video is going to be kind of filling in these sections. And then for the second half, I want you to kind of write all of the things you kind of notice in your own words on the back of the sheet. So we're going to hit the first of the two things, and then we'll hit the second of the two things in the next video. Let's take a look at GeoGebra and see. First of all, we've got this situation where we've got this circle, and I've got a point A on the boundary, and I've got a point B, which is floating around, not on the circle at all. And you can see off here to the left that it says that the length of segment OA, which is a radius of the circle, is 5. And then down here, we have the distance from O to B. And as I move point B around, I want you to notice those numbers and see if you can make a deduction about what those values are when I'm moving around point B inside the circle. All right, so here the point B is really close to the center. Now point B is really close to the boundary of the circle. Now we're just kind of moving all over the spot. So do you have a hypothesis? So it looks like the distance from B to O is changing a lot, but it is always less than the radius of the circle because it's inside the circle. All right, let's say that I switch now and I have point B be outside the circle. How do the distances change now? Once again, they're changing all over the place. Here's a point that's kind of near the boundary of the circle, and now it's getting really far away. And so the numbers are changing, but they always, as long as I'm outside the circle, it's always greater than the radius because the distance from B to the center is greater than the distance from a point that's on the circle. So that's what it means to be outside the circle, having a distance to the center that's greater than the radius of the circle. And then kind of as closely as possible now, make B so that it's on the boundary of the circle. And what are you noticing about the distance there? Well, it might be changing a tiny bit because I'm not very good at keeping it specifically on the boundary, but you can guess that the points that are on the circle have a distance that's have a distance that's the same as the radius of the circle, which is kind of the definition of the radius of a circle. All right, so let me delete that point B, and I want to do one other interesting thing. So I want to create a tangent to the circle that's going through point A right here. All right, and now I'll create a point B that's on this line, and I'll make this line segment again. All right, so once again, we can see the radius of the circle is still 5, and we can see the distance from a point on the line to the center. And first of all, I want you to notice what the distances from B are doing. And the question that I want to ask you is, what point on this line is closest to the center of the circle? And what can we conclude about that point that is interesting? All right, so what we're doing here is kind of building on what we were just talking about a few minutes ago, that all of these points on the line are outside the circle. So their distance is going to be greater than the radius, except for this one point where the tangent meets the circle, and this is on the circle. So that is exactly the radius distance from O. So the closest point from O to this line is where it meets the tangent. Okay, and what can we say let me hide the circle right now. What can we say about the distance from a point to a line? We said this way back towards the beginning of the year. But what can I say? First of all, what do you notice about this line from O to A and the line itself? And do we know that that's a certain thing, or is it just a conjecture? Well, it kind of looks like this is a right angle. why don't we test that? So I'll need a point over here. And so angle from C to A to O, and it came up with that square box, and it says that the angle is 90 degrees, which is exactly what we're used to seeing, that the closest point on a line to a point that's outside the line is where the perpendicular from that line meets the point. All right, so let me put the circle back again. And so we can say that if we've got a tangent to the circle, that it has to be perpendicular to the radius of the circle where it meets that, where at that point of tangency. Between the radius and the point of tangency, that line segment is perpendicular to the tangent that goes through that point. So that's one thing that's really interesting and important to know, that tangents are perpendicular to the line segment from the center to the point of tangency. In the next video, we're going to see a second thing that's really interesting about tangents to a circle, and it's going to be using this fact we figured out here as part of the proof for that. So look forward to that.